Hello everyone, welcome to the 2024 AMC 8 problems. Today we're going to be discussing problems 18 through 22. So let's get started. Problem 18. Three concentric circles centered at O have radius 1, 2, and 3. Points B and C lie in the largest circle. The region between the two smaller circles is shaded, as is the portion of the region between the two larger circles, bounded by central angle BOC is here. Suppose the shaded and unshaded regions are equal in area. What is the measure of BOC in degrees? So we want to find this angle. So we can first find the area of this region. So the radius of this circle is 2. The radius of this circle is 1. So the area of this is going to be the difference between the two areas. The area of a circle is, as you might know, pi r squared, which means the area is going to be 2 squared times pi minus 1 squared times pi, which is equal to 3 pi. The whole circle is 3 squared times pi, which equals 9 pi. So this shaded region is going to be half of that, so that's 9 pi over 2. And since 3 pi already makes up this region, then the difference, 9 pi over 2 minus 3 pi equals this, is going to be the area of this outer region. So one way to write that is 3 over 2 pi. Another way to write it is the arc length formula using the measure of BOC. So if you take this entire outer area, that is going to be 3 squared pi minus 2 squared pi, which equals 5 pi. So this entire outer section is going to be 5 pi. But this area is just a fraction of that. And what fraction is that? Well, it's this angle, let's call it x, divided by 360. 360 is the area or the angle of an entire circle. So this is the fraction of the area that this portion takes up. So we can just multiply that by 5 pi. And this is now the area of this section. Now we can set the equal to 3 over 2 pi. Do some calculations, we cancel the pi. 360 over 5 is 72. We can cancel a 2 here. So we get x over 36 equals 3, which means x equals 3 times 36 is 108. So the answer is A. Problem 19. Jordan owns 15 pairs of sneakers. 3/5 of the pairs are red and the rest are white. 2/3 are high top and the rest are low top. The red high top sneakers make up some fraction of the collection. What is the least possible value of this fraction? So if you have 15 total, then red and white. 3/5 are red. 3/5 of 15 is 9. So the rest is 6, which is white. And for high top and low top, 2/3 of 15 is 10. And the rest are low top, which is 5. So we want to minimize the intersection between red and high top. So for this, we can actually make a Venn diagram of some sort. So this total area is 15. And let's say this area is red, so that's 9. This area is 10 for the high tops. So to minimize this intersection, we want, let's call this x. Then this is 9 minus x, and this is 10 minus x. So this area is going to be 9 minus x plus 10 minus x. These two x cancel out. First of all, this is 15. So this is equal to 19 minus x. So the only answer for this is going to be x equals 4. So the fraction of high top is going to be 4 over 15, which is C. Problem 20. Any 3 vertices of a cube, this, shown in the figure below, can be connected to form a triangle. For example, vertices PQ and R can be connected to form triangle PQR. How many of these triangles are equilateral and contain P as a vertex? So an equilateral triangle has all 3 sides are equal. So let's think about what the side length of the triangle can be. So if you connect any 2 vertices of a cube, then let's say this cube has side length 1. A sketch of the cube. Then the side lengths can be this one, okay, this one, or this long diagonal. By the Pythagorean theorem, this is 1, this is square root of 2, and this is square root of 3. So there's only actually 3 options for the side length of this cube or triangle. So we can try to test some values. If the side length was 1, then let's say this vertex is P. Then let's say this one is the other vertex, and none of these vertices are going to make another equilateral triangle. So 1 is not an option. We can try square root of 2. There are 3 vertices that work for a square root of 2 side triangle. And this does actually work. You can make this triangle, or this triangle. And that's all 3 values. So we have 3 so far. And let's say we want to make a square root of 3 triangle. Then the only point that's square root of 3 away from P is this opposite point, this right here. And there's no other points that are square root of 3 away. So there are no triangles, equilateral triangles with side length root 3 here. That means 3 is our answer. Problem 21. A group of frogs called an army is living in a tree. A frog turns green when in the shade and turns yellow in the sun. Initially, the ratio of green to yellow is 3 to 1. Then 3 green frogs move to the sunny side and 5 yellow move to the shady side. Now the ratio is 4 to 1. What is the difference between the number of green and yellow frogs now? So let's say there are X frogs in total. Then if the ratio is 3 to 1, then there's going to be 3/4 X green frogs and 1/4 X yellow frogs, green and yellow. After 3 green frogs moved and 5 yellow frogs moved, there will be a 4 to 1 ratio, which is 4 over 5x and 1 over 5x, green and yellow. So this changes, if 3 green frogs move to the sunny side and 5 yellow frogs move to the shady side, then that's just the same as 0 green frogs moving and 2 yellow frogs moving, because we only care about the difference. So if 2 yellow frogs move to the shady side, then the number of green frogs increases by 2. So 3/4x increases by 2, and now it's 4/5x. So we can rearrange this as 2 equals 4/5x minus 3/4x. Do some fractions, and you get 1/20x equals 2, which means x equals 40. We want the number of green minus the number of yellow. 4/5 of 40 is 32. 1/5 of 40 is 8. So 32 minus 8 is 24. So the answer is E. Problem 22. A roll of tape 4 inches in diameter and is wrapped around a ring that is 2 inches in diameter. A cross-section of the tape is shown in the figure below. The tape is 0.015 inches thick. If the tape is completely unrolled, approximately how long will it be? Round your answer to the nearest 100 inches. So, judging by all these answer choices, we don't need to be that precise, because they're all like 300 apart. Let's compare the before and after. So this is the before, this is before, and this is the after. The after is going to be a very long and very thin rectangle. The tape is 0.015 inches thick. So this is like a cross section. I'm exaggerating the thickness of the tape, but we don't actually need this length right here. We don't need that. So I'm just not going to draw that. So we want the length of the tape, let's say L. Then these two things have the same area because conservation of mass. You can't create new tape. So the area of this, we use the area of a circle again. Area equals pi r squared. The diameter is 4, so the radius is 2. And the small circle, the diameter is 2, so the radius is 1. So we do 2 squared pi minus 1 squared pi equals 3 pi. This has the same area as this rectangle, which has area L times 0.015. So L is going to be equal to 3 over 0.015 times pi. What? So we divide the top and bottom by 3. This becomes 0.05. And we can move the decimal point 2 places to get 100 over 0.5 times pi. This is going to be equal to 200 pi. Now pi is about 3.14. So if you multiply that by 200, then you get about 628. And that is closest to 600. And that's our answer. Notice how we don't need that much precision for this. Because it's an AMC 8 problem, they're not going to require you to memorize 10 digits of pi. Alright, thank you guys for watching. I'll see you guys in the next one.